So, I first want to start off by talking about what we mean by research data. And research data is widely varied. It can often vary depending on what discipline that you're in, what area of research that you're doing. For today's presentation, we'll be using this definition from the Code of Federal Regulations, since we'll be talking a lot about data management policy, much of the impetus of which comes from federal funders and funding agencies. So they define research data as the recorded factual material commonly accepted in the scientific community as necessary to validate research findings. Now, there are many different types of data that you might encounter or that you might be producing throughout your research projects. Some of them are pretty traditional and things that we think about quite commonly, including like text documents, spreadsheets, questionnaires, code books, maybe image data, spectra, etc. Some things that we don't necessarily think about would be things like standard operating procedures, methodologies and workflows, or models, algorithms, and scripts. So these are just some examples of things for research data and documentation that you might produce during a research project. And these are all things that we need to think about when we're talking about research data management and coming up with a research data management plan. So what is research data management? RDM is really a broad concept that includes all of the different processes that you'll undertake to create organized, documented, accessible, and reusable quality research data. We'll be focusing on the planning stage of that for the most part during today's session. So sort of that early first phase as you're beginning your research project, ideally, but really research data management is and throughout the life cycle of data. And so why manage research data? I sort of like to divide this up into a carrot and stick kind of a model. There's sort of the carrots or the sort of, feel good, like higher level reasons why one would want to manage their research data. One, it saves time. Properly managing your research data is in your best interest because it allows you to locate past or current data and that accompanying metadata, which is going to save you time, frustration, and even money along the way. Well-managed data is also easy to share, which can lead to the data itself being cited, which also allows you to link that data to an original publication or paper if that data set is part of a publication. It helps enhance reproducibility by making the methodology that was used to create and produce the data more transparent. And finally, managing research data also helps you to preserve data. While data management does encourage researchers to consider backup and security measures and proper data storage and things like that, you also want to ensure that that data is preserved and archived for the long term so that other researchers, others in the field will have access to it. So the flip side of that is the sticks. And this is why a lot of folks are interested in data management and why a lot of us think about that while we're working on a research project. Many funders and journals have in the last few years begun to require data sharing as a requirement for funding for a research project. And sort of to go along with that, they require these data management plans where you outline how you're going to share your data, how you're going to work with your data throughout that research project. Accessible data also protects from retraction. If all of that data can be tracked throughout the project, you don't end up with any missing data or data that can't be found later on. So some common data management issues include either not doing it at all or waiting until the end of the project to start. I've had several experiences working with folks where maybe a grant is coming due, you've worked on the project for a couple of years and you're just now sort of thinking about that data management plan or sort of like going back and trying to figure out some of the nuances of that. It's really important to sort of think about that at the beginning of the project to sort of save you time and to save you frustration later on. Utilizing proprietary file formats or sort of non-universal file formats can also be an issue, especially for accessibility to that data and interoperability. If someone needs to look at that data in another software program later on, or if one of those becomes obsolete in 10 years or something like that. So we'll talk a little bit more about file formats later on. And then, of course, incomplete or incoherent data and lack of data documentation. So a lot of the impetus for data management really started and kind of gained steam in 2013 with this memo from the Office of Science and Technology Policy under the Obama administration. And the purpose of this was really to ensure that data produced on federally funded research was made available to the research community and to the general public. And so what it did, in essence, is it required all agencies that receive at least 100 million or more in annual conduct of research and development expenditures to develop guidelines to support increased public access to research results produced by research that was done on federal grants. And this included data, and it also included peer review publications, which is where you might hear about open access and things like that. For today, we'll be focusing on the data side of those requirements. So while guidance for data management plans varies somewhat between each funding agency, different divisions and directorates within those agencies, like we'll see later, NSF has quite a few different directorates and divisions, and each one differs just a little bit on what their exact requirements are. Most data management plans do share some general characteristics with one another, no matter what discipline, no matter what directorate or funding agency that you're looking at. Most data management plans are usually about 2 pages long and ask you to include information about where you're going to archive and share your data at the conclusion of the research project or during the research project. They'll ask questions on data privacy, copyright, and if there's any intellectual property considerations for your project. We'll ask about how you are documenting that data, what sort of documentation that you're producing to go along with the research data that you're producing. It'll ask in general just what sorts of data that you're producing. So the different data types and what file formats are being used, whether that's tabular data or text data or image data or whatever type of data that you're producing. It'll ask you for sort of some outlines and information on that. And then it'll also ask questions on data security and encryption, any measures that you're taking to make sure that data is secure and how that data is being stored, and any sort of backups that you have for that research data in case there's technological issues or something might happen to the data later on. So now I'm just going to give a couple of quick examples. Due to time, obviously, we don't have time to go into every single agency and directorate, but I will show you some resources where you can find that information and utilize that to create your data management plan in a little bit. So this first example is from the NSF Directorate for the Biological Sciences. And you'll see they have 6 different categories, and these are sort of similar to what I just talked about. They include a lot of that same information, talking about the different types of data, the standards that you'll use, sort of the file format and metadata standards, or the descriptions that you might use for the data. We'll talk a little bit more about metadata a little bit later on. The roles and responsibilities of all parties with respect to data management. This is something that's included on not all, but several different pieces of guidance. So who is sort of responsible for executing the data management plan, whether that's the principal investigator or a postdoc or somebody else in the research group, how that data is going to be disseminated after the grant ends, whether it's going to be part of a publication or go into a repository or whatever type of archiving is going to be undertaken. And then any policies for data sharing, public access, and reuse. And this is where one would talk about if there's any intellectual property rights or privacy or security implications for the data. And then finally, plans for archiving that data. What type of repository or what type of long-term archival solution is going to be used. This data sharing policy is actually taking effect next year in 2023, so in a few months from now, but it is a pretty substantial shift. And this is particularly important for researchers that might be on grants or on projects where they're getting funding from the NIH or the National Institutes of Health. The NIH has put out a new data sharing and management policy to replace their outgoing data sharing policy that they've had for really quite a long time at this point. And so this is going to take effect in January of next year. And this requires all researchers on NIH grants, no matter what the size of the project is, to submit a data management and sharing plan. And it includes the elements that are listed here on the slide, which are pretty similar to some of the other components that we've already talked about. So data type, any metadata standards, oversight of the data management plan and sharing. If you're using any sort of software or code or tools or any of that's going to be produced. So this will be taking effect early next year for all new NIH grants. And there's a lot of information kind of coming out this year about that. And so if you do a lot of funding, do a lot of research on the NIH and you have questions on that, happy to answer those or chat at some point after the session as well. So I know that's sort of a big change for that area that'll be taking effect in a few months. So we've talked a little bit about what data management is. We've talked about what data management plans are and sort of some of the general guidance for those plans. So now I want to shift a little bit and talk about a resource that you can use if you're looking to create a data management plan. There's a tool called the Data Management Plan Tool, or DMP Tool for short. That's a really great sort of one-stop shop for all of that different guidance and provides you with sort of a nice framework and templates to craft those data management plans. This tool was actually developed and is maintained by data librarians and other data professionals to help guide researchers in writing their DMPs. All right. So the DMP tool, you can access this a couple of different ways. You can type in the web link, dmptool.org, and this will take you right to the homepage for the DMP tool. You can also access this through the FSU Library's website. If you go to our Research Data Services page, you'll see a link here for the DMP tool, and that will also take you out to the tool. So when you get there, this is what the homepage looks like. And if you've used this tool before or have looked at it in the past, you may notice that the homepage looks a little bit different than it used to. The tool has sort of done a really nice website refresh, and they've sort of added some nice quality of life features that makes navigating it a little more straightforward, a little more seamless from before. So just in exploring it, I've been pretty happy with some of the changes that they've made to navigation and documentation that's been added. So to get into the tool, the first thing you will do is enter your FSU email address. FSU is an institutional member of the DMP tool. So it's really straightforward to log in. You just enter your FSU email and click continue, and then it'll associate your address with Florida State University, the fsu.edu. Then click sign in with institution to continue. It'll ask you to sign in with your FSU credentials, and then you should be able to successfully log in. All right, so when you get to the DMP Tool homepage or your dashboard, this is what it sort of looks like. You should have two things on there. The main thing we're going to look at is this dashboard, and this includes any data management plans either that you've started or that you're working on or that you have worked on in the past. If you're new to the tool, obviously there's not going to be anything there. I've used it for a little while, hence why there's several things listed. So you can always go back to anything you have in progress or old plans that maybe you want to utilize again if you're renewing your grant or something like that. But if you want to create a new plan, you sort of scroll down here to this Create Plan button down here at the bottom of the dashboard section and hit Create Plan. Then it'll give you this kind of quick page for you to start your data management plan. So you can type in the name of your research project. So I can just type in webinar test plan. And if you are doing a plan, which I do this sometimes, if you're doing just a plan for testing, practice, or like educational purposes, like if you're wanting to show students or do this as part of a class, you can check this mock project for testing, practice, or educational purposes. This just ensures it'll show up in a separate pool in the DMP tool stats than normal DMPs. You then select the primary research organization. If you're from FSU, this should be auto-populated, and then you'll select the primary funding organization. So if I say National Science Foundation, like that. And then if your funding agency has directorates or any divisions, you'll see this secondary drop-down menu. And then you'll choose one of these directorates. So like we mentioned earlier, the NSF has a ton of different directorates if you're doing NSF research. So there will be guidance and templates for each one of these directorates, and these are maintained pretty regularly. I am just going to select the generic plan. So this is just kind of the generic NSF DMP template just to show. And then I'll hit Create Plan. And so then you should see successfully created this plan and what template this was based on. All right, so I'm not going to go through and fill in every single little box here, just in the interest of time, but I will point out a couple of quick things. There's several different menus here where you can enter in information about your project and your data management. So there's sort of a general administrative page for project details. There is a menu page to add in collaborators. So if you have any collaborators on this project, whether they're at FSU or another institution, you can add them to this DMP and they can see it, they can edit it, they can interact with it. There is a place here to write your plan, and this is sort of the meat and potatoes where you're going to fill in that information. And what this does is you click on one of these drop-down menus. So each of these sections, right? So either types of data produced, data and metadata standards. You'll see a little text box where you can enter this information. You'll see some links on the right-hand side, and this links out to guidance from the funding agencies themselves. So this directly, you'll say, link out to the NSF proposal and award policies and procedures guide, or frequently asked questions. Then the nice thing is you'll also see guidance directly from the DMP tool. And this is often crafted and curated by folks that are maintaining the DMP tool and data librarians and professionals that are helping to sort of maintain these templates. And you'll see some tips for what to fill in here, some things to think about as you're filling in each of these sections. And so you'll see that for each of these sections. Once you fill in this text, you can hit Save. And you can work on this partially at one point, save it, come back later. You don't have to do all of it at once. It will save your progress. There is also a link here for research outputs. So if you have a data set that is going to be produced as part of this DMP, if there's a software that you're producing or text that you're producing, you can now actually link those outputs with your data management plan. So this is sort of a new feature that's been added to the tool in the last few months or so. And you can also check if this may contain sensitive data or personally identifiable information if you're working with that type of research. And you can also select which metadata standard may be appropriate for your research project. And then the last couple of things, once you have your DMP completed, you can download that as a, say, text file or Word file sort of thing to submit with your grant application. Or if you want to edit a little bit more in a word processing software, you can do that as well. And then the last one is finalize and publish. The first thing is plan visibility, and these are really intended, especially public and organizational visibility for finished plans. So you can make your plan either private, organizational, or public. And private is sort of the default, where it's visible just to you, your collaborators, and any admins at the institution. Organization lets anybody else that has an FSU account with the DMP tool to view this DMP. And then public is where anybody that is using the DMP tool, whether at FSU or not, can view these DMPs. And this is actually sort of a nice little side segue into this public DMPs that you might have noticed up here at the top. So you get a lot of questions, on looking for sort of exemplar DMPs or examples of DMPs that other folks have created. And this is really common when you're sort of first crafting a DMP, sort of looking to see how other successful plans have looked. DMP Tool has this really nice public plans page where they sort of have different plans that researchers have made public. And a lot of these are really good examples, especially these sort of featured DMPs. You can filter these by funding agency. So if you want to look for, say, National Science Foundation, you'll see NSF DMPs from different locations, different funding agencies, what date those were created. So this is a good place to sort of find some example DMPs if you're interested in those as you're working on your data management plans. And then the final little piece here is the DMP ID, which is also something that is new to the DMP tool over the last sort of few months or so. So DMP tool has sort of created this DMP ID to allow you to produce a persistent identifier for your data management plan. And this is something that can also be linked on your ORCID as, sort of another example of scholarship, another output. This is really useful. These plans often take a good amount of work to complete and to work on. You can link these to your research project or other outputs. So this is another kind of nice way to get that scholarship out there. There are a few requirements for this that are sort of listed on the screen. You've identified your funder, you've answered at least 50% of the questions, that you have linked DMP tool and ORCID, which is fairly straightforward. There is some documentation on that that I can link out later. That's a quick little overview of DMP tool. If you have any questions on that, feel free to drop those in the chat, and I'll be happy as we go along here to answer those or provide any clarification. All right, and so I have a couple of slides that sort of summarize some of this here, and we'll be sending the slides probably along with the recording as well. So we've talked now about kind of data management plans, what they are, some resources to help you build those DMPs. For this last portion, I wanted to shift a little bit and just sort of talk about some best practices in data management. And these are things to think about as you're writing that data management plan, and you're sort of planning that research project and how you're going to work with your data. And many of these things tie back into those things that funders are looking for in those DMPs. So this includes documentation of data sets and research methodologies, organization of data sets and documentation, consistent file versioning, planning for data storage and backup, and then making data openly available whenever possible. All right, so data documentation. I've talked about this quite a bit today, and so now I'll talk about what it is and some different examples of common types of data documentation. Right, so data documentation is really information about the data set itself that allows researchers to understand the data and enables other researchers to use and properly cite that data. So you see on the right sort of a data set record from Dryad, which is a data repository. And you see information there about who the authors were for that data, when the data was made available, a persistent identifier for that data, and then a description. So it's really sort of high-level information about the data set itself, and we'll also kind of refer to that as metadata or data about the data. There are many different metadata standards depending on what discipline, what research area that you're in. Different areas have different fields and pieces of information that are of interest. Like some might be interested in experimental conditions or the date and time and like the weather conditions that data was collected, things like that. And some common types of data documentation when you're thinking about data documentation, those include README files. And if you've ever installed a software program on your computer and there's that little text file that sort of comes with the program that none of us ever really read, that's an example of a README file. It gives that sort of high-level information about the data set, some similar information to what's in this record here that's shown at the right, but maybe also including like experimental conditions, links to publications, funding for the project, etc. Another type of documentation that's common in some fields, particularly in the social sciences, are code books and data dictionaries. And these really detail sort of the different variables and the different units and those type of descriptors for any of those raw data values that are produced throughout the project, and sort of describe those for others who might be interested in either replicating that project or in utilizing that data set. And then sort of the final example are sort of research methodologies and analytical strategies. So sort of documenting the different research methods that were used to produce that data that can also be a valuable source of information and something to keep track of. All right, another thing you'll want to consider is to organize project files. I'm sure many of us have at one time or another had like, a computer screen that looks like that on the right, where you just have tons of different documents and data files linked on the desktop, which, as we know, can eventually create kind of a time sink for us to find what we're really looking for. So really coming up with a filing and organizational system at the beginning of your project for all of your data is really key. And that will really help save time, will help with organizing your data throughout the project. It's good to create standards for the entire team if you're on a research team or if you're a PI that's in charge of a lab, sort of creating standards for that whole team on things like how you're going to name your files, at what points you're going to do different versions. If you're producing kind of an ongoing data set where you're producing several different versions of it, you're going to have like version 1, version 2, version 3, how often you're going to version, and then how you're going to organize or store that data. And there's several different ways to organize files, and this will vary for each person. It'll make sense to store it by project, by researcher, by date, by analysis type, etc. So each of these sort of has their benefits, depending on, what your workflow is and what type of research that you're working on. But really the key is to sort of find a system, establish it, and be consistent with it throughout the project. All right, so now we'll talk a little bit about data formats. I referred to these a little bit earlier on when we were sort of talking about proprietary and open formats. And the main thing to take away from here is that in order to make your data more reproducible and readable by future researchers and by new software versions that come out in the future, we highly recommend that you save or archive a copy of your data in a universal or non-proprietary file format. And those are the formats shown on the right-hand side of the screen in the rightmost column. So formats like text files or CSV files or TIFF files or PDF files. I will say, I don't want to say that you can't use some of these proprietary ones. These are definitely okay. You know, a lot of us use Microsoft products, or we're using instruments that might produce kind of their own format of data. And it is fine to have these saved kind of as you're doing your data project. But definitely sort of when you are doing that sort of final look through of your data, you know, you're storing it, archiving it for the long term, I definitely recommend archiving at least a copy of that in one of these universal formats. And then data storage and backup. I sort of like to use this sort of acronym LOCKS. Lots of copies keep stuff safe. We like our acronyms, you know, in academia. So but really here, it's important to back up your data regularly over the course of a project to prevent data loss, right? Because things happen with technology, data might get lost, you know, on a computer, something happens to that piece of equipment. It's important to come up with a good plan at the beginning and stick with that plan. Come up with this before you collect any research data. A good rule of thumb for this is sort of the 3-2-1 rule. So keeping 3 copies of your files in at least 2 different locations. If you have it on 2 different places or 2 different copies, but they're in the same area, same location, if something happens to a piece of technology there, you might end up losing both. So keeping them in at least a couple different locations, and preferably at least one of those being off-site. A lot of folks will use like cloud storage or an external server for this, but there are several options. It's important to make sure that that data is backed up often and select a schedule for that works for you. So whether that's daily or weekly, make sure that that data is getting consistently backed up. And when we think about data storage options, there are many, many different options. Each of them sort of have their benefits and their drawbacks. There's not sort of one size fits all best storage option. Each piece of technology or location has good and sort of not so good things about it. But I will say that when you're selecting how and where to store your data, there are several things to consider. That includes what type of protections you need for the data, you know, whether you can protect the integrity of the data, access to it, etc. Whether you're dealing with confidential or restricted data, whether your data is sensitive and how sensitive that data is. How important is it to be able to easily access the data, and who is able to access that data? What permissions does everyone have? Whether you are collaborating with folks, either internally or externally, that's going to affect which options you select. The volume of data, so how much data do you need to store? You know, is that 5 megabytes or 5 terabytes? And then whether you are looking to use either something on the network, whether it's a external server or a server through ITS, or maybe it's a cloud-based program. All right, and sort of the final thing I believe I'll talk about before wrapping up is data repositories. And so this is really getting into data archival. So we talked about data storage as you're sort of going on your project, you're sort of working, producing your data. Then you need to archive that data for the long term. And so really sort of the best place that we recommend for this is often what we call a data repository. And these are sites that curate and archive data in a way that is fair. And so you may have heard this concept of fair data. Different funding agencies are really, really interested in making data fair. And that really stands for findable, accessible, interoperable, and reusable. So making sure the data is findable and can be accessed by other researchers and programs, that it is sort of universal, can be accessed by different software, and that it's reusable by others in the community. And there's a few different types of data repositories, and I'll just briefly kind of cover what those are. There's discipline-specific repositories, such as ICPSR, which is the Inter-University Consortium for Political and Social Research. It's a social sciences data repository. Dryad is another common repository for sort of biomedical related research, amongst many others. And a really good place to sort of find a listing for these different discipline specific repositories is this site called re3data.org, which is the Registry of Research Data Repositories. This has at least 100 some repositories, probably more than that. If you are interested in depositing your data and you're looking for a good repository, if there's maybe not one that's recommended on like your grant call, sometimes they'll specify we want it in this repository, but a lot of times they won't. So this is a really good resource for that. We also have institutional repositories. A lot of different universities have set up their own repositories for data and for publications and things of that nature. At FSU, our institutional repository is Digital, and so that is managed here internally by the libraries, by our digital research and scholarship team, and that houses some data sets and any publications in there as well. So that's also an option if that fits your project. And then there's also in some countries, some areas of the world, there's also these national repositories, which sort of take research that's produced at the national level in different areas, such as the UK Data Bank. That's also another example of a data repository. So these are really good options for sort of archiving your data for the long term so that researchers in the future can access it and utilize that. All right, so I've presented a lot of different information today, sort of broad overview of data management plans, some things to think about when you're working on those and when you're managing your data. I put some links on here to some other resources that I haven't linked previously. We do have a data management policy here at FSU, and this really sort of affirms using those federal funder guidelines or private funder guidelines when you're working on your data management plans. And then there's also a couple of other sites, Spark and ICPSR have some good links on, research funder data sharing policies and guidelines for effective DMPs. And then finally, we here at the libraries are here to help you anytime that you have questions on your data management plan. If you want to sit down with me or someone else here at the libraries to talk about your DMP, if you have questions, if you're just starting out, if you want to go through the DMP tool and set up your data management plan in there, we are more than happy to do that. We have a library guide that provides some good information and resources on data management. And we can also help with finding and selecting repositories, archiving your data set, and helping with any other data management tools. And with that, I'll just put my contact information on the screen. If you have any questions at any point after today, please feel free to give me an email, set up a time to chat. More than happy to do that. I've also linked our Research Data Services webpage. There's a lot of folks on there that also do work in data here, both in the STEM libraries and throughout the libraries. So depending on what discipline you're in, there's a lot of folks that would be more than happy to help. So with that, thank you very much, and I'll open it up to any questions.
Thank you very much for a very interesting presentation. At the beginning of your presentation, you mentioned required sharing for funders and journals. Were you referring to the data management plan and or the data itself?
So the data management plans are required by funding agencies and funders whenever you're submitting a grant application. And usually within there, they also have policies for sharing of the data itself. And so within those plans, one of the sections is you outline sort of how you're going to share that data and sort of meet whatever public access guidelines that those funders have. Evangeline, did we have any questions from the chat? I cannot see it.
Looks like we just got a couple. The first one says, question about data repositories. Does the FSU library assist with setting up a digital repository for current research, which involves data collection of video or audio recordings?
That is a good question. I'm guessing sort of you're talking about like taking some video recordings and other data produced with that and setting up like a repository like for that information. We can help with that. We do not have anything just like unlike FSU libraries infrastructure, particularly for things like that. But I am happy to help with projects like that and finding resources and tools where you can sort of set up a project and link to different like videos and data files and documentation for that. So happy to chat, more and sort of find out the specifics of that if they're interested.
That sounds great. And I see another question we have is, what are the options for storing large amounts of DNA sequencing data prior to their publication? And they say in parentheses here, following which they can be uploaded to public databases.
Yeah, so there's quite a few different repositories for that. I'd have to go and look at some of the different repositories that are out there. There's hundreds of them, but GenBank sort of comes to mind as one repository. Once you deposit it, it does become publicly available and you does create like a persistent identifier to that. And a lot of times that can be linked to different like public databases and like websites and things of that nature. But there are also options, I believe, that if you're sort of wanting to mediate, kind of when that data comes out and that sort of thing, there are options for that as well.
Do we have non-public repositories, like temporary storage possibly at FSU?
That is a good question. Our institutional repository is public. So that I know is public. And a lot of repositories, kind of the way they're set up, do make that data publicly available. There are potentially some resources through ITS. Different departments might have some servers or some space set up where you can store that. Some cloud-based systems that we have access to at FSU, I believe you can store that temporarily and then sort of upload that to a repository once it's ready or like once the data is complete.
All right. Yeah, it looks like those are all the questions we have in the chat.
All right. Well, we are running up on the top of the hour, so I'll just sort of finish up real quick. So thank you all very much for taking time to attend today. Thank you to Evangeline and Office of Research Development who've helped coordinate this session. And as I said, if you have any questions after today, please feel free to follow up. I'm very happy to work with any of you as you're working on your data management for your projects.